Yeah, today we're going to talk about Agentic AI and how you can build applications for doing dynamic decision making. So my name is David Von Thenen. I am an AI ML engineer at NetApp. I have been in the AI and ML space for some time. I typically do NLP related stuff, so that's natural language processing. But I have a ton of other interests in the AI and ML space. So I like to do AI on edge, so IoT edge devices. I like to do vision-related projects, and I even build medical models to detect debilitating diseases. Prior to that, I was in the Kubernetes and CNCF ecosystem, so doing open source Kubernetes, CNCF Cloud Native Computing Foundation, so a host of other projects that they provide to manage, run, and configure Kubernetes workloads. And prior to that, I was in the backup and recovery solution space doing virtual machine backups, specifically for VMware vSphere. So the agenda today, we're going to talk about how agentic AI can literally transform your applications. And the talk was originally a CrewAI talk, and we're definitely going to talk about CrewAI. It's actually an awesome framework. But there's a ton of buzz these days about MCP and agent to agent. So I'm going to literally bring all of that in, and we're going to talk all about it and actually integrate all of them all together. So it'll be pretty cool. So again, CrewAI, we'll talk about CrewAI and how you can use it with MCP. So that's a model context protocol. And then we'll compare and contrast to agent protocol. And then you can see demos, 4 live demos we're going to do right here, and then have some Q&A at the end. So, transforming your apps using agentic AI. So maybe even to step back for terminology, there's people are talking about AI agents and agentic AI. So what's the difference, right? So AI agents, kind of at a basic fundamental building block level, they're kind of like LLMs, right? They're task-driven. You give them a prompt, give them a blueprint, right, to what you want as the output. Here's the information you need. You get a goal, right? What do you want as a form of output? Now you compare that to agentic AI. Yes, you have a goal, right? You ask it an agentic system hey, I want something, and it needs to give you a response back. But how it gets to that response is very, very different than an AI agent. So an agentic AI system is basically turning the keys over to the AI system in order to figure out how to get to that end state, to that goal, that response. And that's the big difference. And so because you're turning the keys over to this AI system to figure out how to get to the end, it's kind of non-deterministic, right? Because you have no input in how it gets to that end state. And so how you get to the goal is very different than how you get to the goal for an AI agent. So very different, AI agent versus agentic AI. An agentic AI system, because it doesn't need much human intervention in order to operate, how does it do it? And it's pretty simple. It's kind of actually, oddly enough, how we humans do it. You plan, you iterate, and then you eventually get to an end state, right? And so because there isn't any human intervention, we have control loops that are kind of hidden away in the context of the AI agent, the agentic system. And so you do a bunch of analysis, you go do research, you find out, hey, am I done yet, right? It's actually the kids in the back of the car saying, am I done yet? Are we there yet? Are we there yet? And if the answer is no, more research, figure out how we add to our knowledge set in order to get to the end goal, which is the response back to the user. And because that's the control, right, loop until we get research, are we done yet? We have to have memory for these agentic systems, right? We have to know what we've already done so that we don't repeat ourselves. And we also have to know what things we have left so that we can progress to the end state goal, right? The response. And along the way, you can call APIs, you can search the web, you can do all sorts and hook up all sorts of tools in order to make that process happen, right? You have agentic AI. What's the big deal? So if you're turning the keys over to how an agentic system gets to an end state, a goal, a response, you literally are taking the human out of the loop. And so what does that really mean? It means automation, automation, automation. And you can do literally anything that you can dream up with an agentic system, whether it's content generation to create images, completely automating business processes, operationalizing tasks, right? So like, robotic systems building cars in a factory, right? Which, by the way, have been going on for decades now. So how does this work? So using an AI system, right, an AI agent, so the non-reasoning stuff, we kind of tricked our way to getting to an agentic system by doing a chain of thought prompt, which is, hey, here's the background information you need. The chain of thought part was, here, I want you to go through step 1, step 2, step 3, right, in the beginning of your prompt. And then you would say, this is the output that I want. Now, in an agentic AI system, you basically say, hey, here's what I want you to go figure out. Here's maybe the steps along the way, but it's going to determine how to break up those steps, what research tasks or tasks it needs to do in order to get to that end state. And it's going to iterate until we get to that final answer back to the user. So I've kind of said it twice already in the slide after slide. It's really dynamic decision making. No human in the loop, it coming up with the answer, doing all the research to figure out what the end response is. So by a show of hands, who here has used OpenAI's deep research? Okay, a few people. I think it's actually, you can use it a few times for free in the free tier. I would definitely go implore you to take a look at it because it greatly describes like what I'm talking about. You give it a problem. One example I did was, hey, go research doing a voice cloning for text-to-speech. I gave it a few examples of like what open source projects are out there. I literally hit a button. 15, 20 minutes later, it came up with all of the research. How do I start using open source software, all the code examples, and literally saved me 2 or 3 days worth of research doing it on my own. So that's kind of like the power of like what I'm talking about here today. So we went from a kind of a high level to a more concrete and a more like more concrete example here, and we're talking about CrewAI today. So CrewAI is an open source Python framework. It is role and task-based orchestration. And the way it works is you define a bunch of AI agents, so think like just LLMs, to build an agentic AI system, right? So I'm using those terms. So an AI agent, just kind of like an LLM, armed with a bunch of tools to build an agentic system, which is AI agents working together in a crew, which is actually why it happens to be called CrewAI. So if you have a bunch of these AI agents, or LLMs, working together, each agent represents like a specialization. What am I good at doing? It has a particular area of expertise. Think of them as like subject matter experts. So they collaborate together in order to reach that end goal. Like, what is the answer that I'm providing to the user? And what's very interesting is that you define a bunch of tasks that you want your agentic system to do. Those agents will kind of delegate work to each other based on what they need at that time. And they will also impart any kind of tools that you decide to provide them. So that's searching the web, going and calling API calls for like SaaS platforms, whatever it is you want, you can arm them with tools to go ahead and do that. But the bottom line is CrewAI is a very, very opinionated framework because you declare your tasks, you declare your agents with the roles they have all in code, right? And so that's why it's an opinionated framework. So instead of talking about it, let's go ahead and take a look at an example. So here we have a the most simplistic CrewAI example that I can give. And it is 2 agents. One is a research agent, and then the other one is a writer. And the first research agent is basically, it's able to go research things. And the second one is, hey, you're a talented writer, so that you can go write blog posts, and those are actually the tasks that we're going to give them. So the first task is research something to distill findings into crisp bullet points, and then based on that information, we're going to craft a 3-paragraph summary suitable for a technical blog post. And because we have tasks and we have agents and we form one crew, this is how CrewAI works. So let's go ahead and run this example. Hopefully the internet will cooperate. Yay! So you can see here, top one is research, which is completed. So it's done the research for it. And then the final outcome is we want to report a 3-paragraph report on the research that we've done. And this is the final 3-paragraph blog post that you can see right here. So the most simplistic crew or agentic AI system, 2 agents, each given a task, which is go research something, go write something, and this is the output for it. So it's pretty powerful what you can do in such literally a short amount of code. So now that we kind of know, and we know how to build an agentic AI system, let's talk about MCP, because that's what everyone's talking about these days. So what is MCP? So MCP stands for Model Context Protocol, and what the claim to fame for it is it's how to provide content, information, data sources to LLMs or AI agents. And it's a protocol, which means all it does is it defines how to connect LLMs to these data sources, right? These external data sources. And the data sources can be anything, right? It's an API, it could be database information, other agentic systems, other LLMs. It could be literally anything. And the way the LLM or the AI agent accesses that and queries that information, it does it by a MCP client. And the MCP client, so LLM invokes the MCP client. MCP client points to an MCP server. And underneath that MCP server can be whatever you dream up to implement for what you want to provide your LLM. So hook it up to a database, make API calls to some SaaS platform, something that your company makes, whatever it is, you can take that information and feed it back up to the LLM. Again, ultimately, what MCP is, all it is a protocol, which defines basically defines the capabilities of what that MCP server does and how to do the information exchange between what the LLM wants and what the LLM or the MCP server provides in response. So it's a single unified protocol. I'm a picture person. I'm a very visual learner. And this is an awesome picture. It's not my picture. I gave credit to the person there. This is an awesome picture about what MCP literally is. So we have, let's see, my pointer will work. Yes! We have an Claude, right? It's an LLM. They call them MCP hosts, whatever. An AI agent, an LLM, uses an MCP client, and then the MCP protocol is literally, this is the best representation of what kind of like MCP protocol is. It's a hub to connect any service that you want to an LLM. And that's the really, really cool part about this. So if your LLM needs to access Gmail for whatever reason, it uses the MCP protocol to contact an MCP server to get Gmail information and bubble that up back to the LLM. Now, if we double click into what that actually looks like and why this is really, really powerful, on the left-hand side is what we did before MCP, is if you wanted an LLM to access external resources, whether it be an API, a data source, or whatever, you would use client-side function calling on your LLM, implement some SDK, Slack SDK, Google Drive SDK, GitHub SDK. You'd have some code implementation to do the function calling for your LLM to connect to those things. Now, after the advent of MCP here, you have that unified protocol, and the MCP client, your LLM uses an MCP client, contacts an MCP endpoint, which is that middle piece right there, and that MCP server, or that implementation there, that is what consumes those very specific APIs or whatever. So we've literally decoupled the two. And the cool thing is, even though your MCP server, one might be implementing using Slack APIs, and you have maybe another MCP server that knows how to use GitHub, the protocol for your MCP client to connect to each of those MPC servers, even though one does Slack and the other does GitHub, is the same. And that is the really cool, powerful part, is single protocol to exchange information regardless of what the underlying capability of that MCP server is. And that's literally the power behind MCP. CrewAI has the capability for hooking up simple tools to your LLM, but think of MCP as the everything toolkit, right? You can hook everything up to an AI agent or an LLM. And not only that, but you can provide new capabilities and new functionality to your LLM. And that kind of brings an interesting question around now, right? If you have new data sources that you can expose to your LLM doesn't really need to know everything, right? It can go and query these external data sources to get that information. You're kind of now decentralizing, in a way, the knowledge of where that information sits. It doesn't need to sit in your LLM anymore because it can use MCP to access it. So maybe this is kind of the new RAG, right? Because you can say, hey, go and call this information, grab it from an MCP server, and the LLM, as long as it understands language, which it does, large language model, it will go crunch the language in order to figure out what it's saying. So kind of the other caveat to that is we're really now truly talking about dynamic real-world actions. And MCP is kind of like this cool Swiss Army knife that LLMs now have, right? They can access all sorts of endpoints with all sorts of capabilities, and it's completely distributed. So let's go ahead and give an example with CrewAI and an MCP endpoint. I'll just go ahead and open this up really quick. I'm using OpenAI only because running an LLM on my laptop is very resource intensive, but you can see right here, there's a local llama version too for all these examples. But if we go ahead and we open up, take a look at our previous example, 2 agents, 1 researcher, 1 writer. I gave it the capability of understanding to go and query PubMed tools, which is a huge online repository for medical publications. And so the researcher can now go research and pull information from PubMed. We have the same research tasks, go research something, go write something. And we also then have our MCP endpoint within the same process here. So if we go ahead and we just run that, I just don't want it to do that because it's going to take too much time. And if it doesn't come and give me a blog post at the end, then I'll just cut it off. Yeah, so it's over-researching. Anywho, so the fact that it will give you a blog post at the end, take my word for it, you can run it at home. But what's actually the most interesting part of this is it's actually pulling in real time PubMed articles, and you can actually see the HTTP requests going out to PubMed in order to grab that information in real time. So that's kind of like the power of MCP, is that it can grab that information dynamically. It didn't need to be trained. Your LLM didn't need to be trained on PubMed information, right? You didn't need to create a RAG agent in order to train it, fine-tune it with the PubMed information. It's doing it dynamically in real time. And so kind of that's one huge takeaway for MCP. So cool. So now let's talk about, since we've been talking about CrewAI, and now we know how to use CrewAI plus MCP, what's this deal with agent to agent that everyone is talking about? So agent to agent is a protocol. It was developed by Google. And what it does is it's a protocol for multi-agent interoperability. And they communicate, so if you're talking about multi-agents talking to one another over a known agent-to-agent protocol, that communication is done over HTTP, HTTPS, but the key right there is HTTP, HTTPS, distributed, right? They can run anywhere. You can run them locally on-prem, you can run them in the cloud, they could be a SaaS service, right, that your company provides. But the idea is just like in that CrewAI example, each agent is specialized to handle, like as a subject matter expert to handle, processing of certain tasks. And because Google developed this initially, they have that, the agent-to-agent protocol, they have an implementation of doing agents talking to agents in their agent development kit, or, which is the second link, there's a reference implementation for doing agent-to-agent protocol if you don't want to do Gemini things or Google things, right? So agnostic implementation. So implement it, but again, the cool thing is agents can talk to agents. The agents can be anywhere at this point. Local, remote, cloud, SaaS service, wherever, right? It's just an HTTP endpoint in order to communicate with one another. So think decoupled, right? A decoupled agentic AI system where the agents can live anywhere. They can all talk to each other, and they can subscribe to other agents to do work on their behalf. So this is the simplest implementation architecture for doing agent-to-agent protocol, right? Using agent-to-agent protocol, thereby making it so you can have two agents communicate with each other. So you have one agent on one side, another agent on another. Agent-to-agent protocol is how you can communicate. How your agentic system looks, right? It could be using multiple LLMs to one logical agent. So you can have an LLM talk to other LLMs, but the whole idea is in agent-to-agent protocol, you have eventually this hierarchy of one agent that is a subject matter expert that can process this type of information. And it turns out that they can use MCP, right? Because we're just talking about LLMs. Agent to agent, they can talk to each other, but the LLMs individually can use MCP or whatever tool set they need in order to go do more research, access more information. So then, what's the difference between agent-to-agent protocol and CrewAI? And this is kind of like the real meat of the thing here. So the difference is that CrewAI is an opinionated framework. When we looked at the code, you had to define your agents, and those agents we just used OpenAI. It could have been Llama 3. It was just an LLM, but those agents were defined in code. Not only that, but if you remember, those tasks were also defined in code. So you can have agents talk to each other, but if we're defining it all in code, it's in one process on a single system. And that's the difference. Multiple agents talking to each other, they can access MCP and all the tooling that they need, but it's on a single process in a single crew on a single system. And because you're defining those tasks, that means you have a very heavily workflow-driven agentic system. I need you to do these 5 tasks. You have these 5 agents that can come up and find the answer to that particular solution. So if you have defined tasks that you as a human defined, and you also define the agents, scaling that becomes very difficult. But the good news is because you're defining those tasks and you're defining the agents, getting that up and running is actually very quick, very easy. It's super fast. And so what is this? So what is CrewAI really, really good for? Agents talking to each other, where you want to quickly build an agentic system, but it's all workflow driven. Like this agent is good for one thing and like kind of like one purpose only, which is good because that happens to be our definition of what a subject matter expert is, right? So now, kind of, we have MCP, we have CrewAI, we have agent to agent. So this is what a simple agent to agent architecture looks like. You have a client that's going to ask a question. It needs something, right? It needs an answer to a question. It's going to call down to an agent. So this agent does all of the coordination, and it can talk to two other agents. We have a question and answer agent, which is very specialized in answering questions. And then it can also talk with or delegate tasks to a summarization agent. Given a huge amount of text, I want you to summarize what this thing says. And they can all talk to each other, and when the agentic system finally arrives at an answer, breaks down all the tasks, does everything it needs, when it reaches done, that coordinating agent returns that response back up to the client. So, and again, at every step of the way, because agent to agent is only defining agent to agent communication, and MCP is only talking about tools that LLMs can use, those two things are completely orthogonal to each other. So you can use both in a system, which you can actually see right here, right? So a lot of people might be asking, how does that coordination agent work? And in my implementation, and I think it's actually a pretty clever implementation, and it also happens to be a very simple implementation, that coordinating agent, I'm actually just going to use an LLM's function calling, saying if you need to do any kind of question and answer stuff, do this function call. This function call actually happens to be hooked up to the agent-to-agent protocol, which then sends the request over to that question and answer agent. It does its thing, and then gets the answer back through that function call, through agent-to-agent protocol, through the function call, back to the LLM. And so that's how I've chosen to implement this coordination agent in this demo. So we're going to start our question and answer agent. So HTTP endpoint, right? This is just a simple Flask application. We're going to start the summarization agent. Again, another endpoint. And then we're going to start our coordinating agent, another endpoint, using agent-to-agent protocol to talk to each other. And then we have our client, which this is our implementation for our client. Here's our coordination URL, again, HTTP. It's going to, given this huge blob of text, I basically kind of copied and pasted NASA's Artemis program. And the program is designed to figure out how to do sustainable presence on the moon, and gave it a whole bunch of this text. And then also, what is one major engineering challenge not mentioned in the text provided? And so that's what we're going to run right here. So that huge amount of text, it said, I need a summary of this. The coordinating agent said, I need a summary of this. This is the summary, right? Much more condensed. There was that question that we had at the end, which was name something that wasn't mentioned in the blob of text that I gave it. And then here's the answer. One major engineering challenge not mentioned in the text is the propulsion system developed for efficient travel to and from the moon. The coordination agent returned 200 back to the client. Here is our summary and our answer, right? So the coordination agent, again, enlisted the help of two subject matter experts, one that can answer questions, one that can do summarization, did all the coordination to return this final answer back to our client. So, pretty cool so far, right? And it's pretty cool how you can like build agentic systems pretty quickly. And again, we've seen CrewAI, where you can like very declarative, opinionated framework, very simple, very quick, and very easy to get an agentic system up and running. Build a subject matter expert to do whatever. MCP, think of it as Swiss Army knife, hook up any tool to any LLM or even an agentic system. Agent-to-agent protocol, if I want to have multiple agents in a distributed fashion talk to each other, that's how they go ahead. That you use agent-to-agent protocol to make that happen. Can we do all of it together? And the answer is yes. So, the Uber example, right? I'm going to add a fourth agent, and that fourth agent is this image creation agent, and it's implemented using CrewAI. And so, kind of like with the, I'm going to feed it the same exact prompt, slightly, and the image creation agent, based on the context of the conversation, is going to give me an illustration. So it's going to output a PNG file, knock on wood with the internet here. It's going to give me a PNG file that's kind of like an illustration based on like the conversation that these LLMs are having with each other. And so let's go ahead and hopefully give that a try. See, this is how you know when it's really real, is when you need to start switching directories. Okay. Here we go. Image creation agent. The question and answer agent. The summarization agent. The, I can spell, I swear. Whoa! The coordination agent. And then we have our client, which we're going to take a look at. And it's literally the same exact code with one small, tiny detail. Create an illustration capturing this context. Otherwise, it also was one major engineering challenge not mentioned above. So let's go ahead and give this a try. See which one's going to respond first. See, that's like kind of, right? Because it's, I'm turning the keys over on how it's deciding to solve the problem. So I don't know which one's going to pop up first. So I guess that's like yet another good example of how, what is doing what. Okay, oh, that's because the image creation was like, so we got the question and answer here. So what engineering challenge is not mentioned above? So we got an answer to that. We'll probably get the summarization happening at any second now. We have an image that got created based on the conversation that's happening. And I'm using, just because it's OpenAI, again, I can't run an LLM locally on my M1 here. So I'm using Wall-E 2. You can use the new GPT image 1, but it's very expensive. So just for demo purposes, I'm using the cheaper version. And, of course, it didn't fail to download. Anywho, so we have a reply. So one engineering challenge not mentioned above, and the image failed, but I actually have an example of one based on what a previous run looks like. So this is just an image from a previous run. So cool. Man, I really wish this would work. Let me give it one more time. Give it a couple more minutes. So as we're letting this run one more time, any questions so far? Yeah. Yeah, so that's a great question. So if you, like basically the crux of the question is how do you prevent an LLM from over-researching? And you can already see that oh, yes, it worked this time. So here's the, sorry, I'll get back to it. Here's the summarization. the image, the question that got answered, the image got saved. It's always interesting to see how these things decide to draw themselves. Different. Again, if you use the new image creation model, it looks a ton better than this. This is just, again, like I said, the cheap version. But now to go back to your question, so that depends, right? So it depends on how, right? One of the aspects of MCP server or even the agent is you're describing what this agent is good at doing, and if you don't make it distinguishing enough to determine which one that's going to use, so say this one is really good at making images in outer space, and this one's really good at making like puppies and rainbows, and if you're not specific enough, it will just probably pick one. And that's kind of one huge point of this is you're turning the keys over for the decision-making process, so it's going to just pick whatever random one if you're not specific enough on the advertising of the capability for that particular the agentic AI agent, right? And then go back to your first question is like, how do you prevent it from over-researching? So you can see in my second demo, I actually intentionally didn't put any kind of cap on it. Usually it finished much faster, but if you don't put a cap on it, it will continue to do it until it exhausts or it decides that it's done. Part of the problem was that it was grabbing articles that I hadn't seen before, and so it was kind of going down this rabbit hole of researching. Another way you can tackle that problem is in CrewAI, you can say, hey, when you go research something, grab 3 things. And I didn't do that, right? But you can say, go grab 5 of the top 5 articles, and you can limit it that way, right? Based on the task definition that you're doing. So CrewAI, again, because it's like declarative, right? You declare what you want each task to be. You can limit based on the task. Now, if you're talking about like turning the keys over to like a pure like agentic thing, you can still put it in the instructions, but the part of the problem is like, again, you're turning the keys over because it's not declarative on what every task is supposed to do. Your results are going to wildly vary, even depending on when you run it, right? Because if OpenAI has model V3 running, and the next day under the covers, you don't know that they've changed to V4, you're going to get a completely different answer, right? Yep. So, and by the way, to reproduce, so again, I'll get to the resources in a second, but every demo I've done today, I've included YouTube link, so you can actually see this demo pre-recorded at home. Hopefully there's no funny backdrop or anything, but it's pre-recorded so you can see like exactly what I demoed here today. So yeah, just to summarize, we've got 8 minutes, cool. So we'll have a ton of some Q&A at the end here. So the big takeaway, so CrewAI is good for workflow-oriented use cases. Define tasks, define agents. You are literally setting the scope of what the agents should go and research, how it achieves that end goal. It's great for prototypes. It's great for standalone agentic AI systems. Building multi-agent apps within one standalone application is really easy, right? Because it's all in code, defined in code. They can share resources amongst the agents, which is really cool because it's within one crew or one process. So handing off information from one agent to the next is super easy because you can do it in code. And again, CrewAI can leverage MCP endpoints. So it can access any external source of information that you decide to implement. Model context protocol, right? Swiss Army knife. You can access through using an MCP client, connect to any MCP endpoint, which can implement whatever, right? So if it's a Slack endpoint, the advertisement, like what its capabilities are, is like this thing can go and find out what the hottest trends are happening in Slack right now. And so when you ask your LLM, hey, like go find some AI, cool things that are happening in AI, it will probably go down to your MCP endpoint that says, here are all the Slack messages that are talking about the coolest things that are happening right now, right? And that's how you're like literally making the association between the advertisement of what it's doing and like how the LLM figures out how to connect and pull that information. And then agent-to-agent protocol, right? Which is, think distributed agentic AI systems or agents talking to another. They don't have to be all contained within a process. They can be distributed on-prem, cloud, SaaS, whatever the heck it is, right? As long as it has an HTTP endpoint. But ultimately, at the end of the day, you can use all of that, like in that last demo. CrewAI, agent-to-agent, MCP, all intermixed and however you want. Maybe your LLMs are connecting to OpenAI. Maybe they're Llama 3. Maybe it's some RAG platform you've created, so it's super specialized in something. There's no reason why like, you need to put anything. You can put everything on the table. You can use all of the tools that you have with what I've shown you here today. So resources. So this is my GitHub repo. This has all of the code that I literally demoed today. So all 4 of those demos, the code sits in that repository. Just the, right, 1, 2, 3, 4. All the code's available there. So you can have at it. Oops. There we go. Yeah. If you're interested in continuing the conversation, I work for NetApp. You can go ahead and scan those little QR code, talk to me on Discord. Happy to chat about anything AI, ML. Here are the links for CrewAI, MCP. I come to find out that this, I guess, is a very Java-heavy conference. So first time to Devoxx UK, so I'm happy. And first time to London, by the way, so it's awesome. But here is the SDK for implementing an MCP server, an MCP endpoint that you can hook up to an LLM, right? Because you're just talking about MCP protocol. What that MCP server can literally be any language implementation for an MCP server, right? And so you can have, it could be a Java MCP server passing information back up to your LLM, and then the link for Google's agent-to-agent protocol. And that is it. We've got 4 minutes and 32 seconds for questions. Otherwise, I hope you enjoyed the talk, and yeah, cool.